Okay, cool. So got a good number of folks here tonight. So thank you everybody. This for joining us. This is the monthly meeting for the Astronomy Fundamentals Special Interest Group for the Tucson Amateur Astronomy Association. That's a giant mouthful of really big words. So for those, because there's some names I haven't seen joining us tonight. The usual format for how this meeting goes is we typically have two presentations that are given. One is typically a shorter presentation. In the past, we were doing this as a constellation of the month, and we've kind of sort of transitioned over to doing an astronomer spotlight after we ran through all 88 constellations earlier this year. And then after that is a little bit of longer of a main topic in terms of a presentation. Doug Smith will be giving the main topic presentation. It reminds me, I need to make Doug a co-presenter.
Thank you.
Add it. What else is there? So, and some announcements where I actually can say, hey, here's some presentations we're looking at for once, kind of ahead of time. I'm thinking sometime in October that I will do a main topic presentation on using the Celestron hand controller and some of the functionalities that are available in it. I know that we've it's been kind of a while since we've done an equipment presentation, especially given, the virtual setting. So I think I got a way to do it where it's not just here's a presentation with a bunch of screenshots. But I need to do a little bit more prep work to see if it's going to work. So hence the pushing that into October. If that does work, I would also be interested in looking for anyone who'd be willing to volunteer doing something similar for Meade's hand controller or for astrophysics hand controller. I know that there's obviously between all those hand controllers, even if it's the same manufacturer, there are some slight differences between, hey, I bought this controller, 15 years ago. So there's like some different layouts depending on when you actually bought the controller, but I still think they would be a good thing to have, especially for people who are coming in and say, hey, I don't know how to use this hand controller. What do all these menu buttons mean? So I don't want to go and read this giant manual that I don't understand. So I think those would be some good topics that I think others would enjoy.
Hey, Connor.
Mm-hmm.
Are we expecting to ever get back to doing live in-person AFSIG meetings? It's
it'll be a struggle to find a place to host it, especially we obviously there's been a lot of interest in continuing to still do a Zoom presence for these meetings because we have a lot of people who are snowboards and things like that who attend these meetings now that they're virtual and they can. So I've just been preoccupied with a job change and some other things.
I was just asking, are we even thinking about that?
I haven't, but I know that it's been something that's been kind of requested. But I need to find a venue.
All right.
That's kind of the only thing is just like me finding time to go find a venue that can host the meeting.
Because clearly doing talks about equipment would be easier in a live venue.
Well, not for the hand controller, not really, because it's
right. But if you're doing,
but for others,
bring a telescope in or something.
Yes, for others there where it's not like here's this one tiny little thing, let's huddle all around me. I agree.
Yeah. Okay, just asking.
No, it's been on the back of my mind, just not a priority because, as I mentioned, I recently started a new job at the end of last month, so it's been kind of a whirlwind of adventures. And so with that, I'm going to go ahead and get started. So the two topics we have up tonight are one the one that you can see on the recording right now is about Giovanni Schiaparelli. And then after that this should be fairly short. Unfortunately, I was not finding as much information on him as I had expected. I probably would have needed to go look at some physical books or his biography in the library if I could have found them. And then after this, we will transition over to Doug and his topic, which I'm told should be quite interesting.
Different.
Your words.
Interesting, I hope. Different for sure.
Okay. Cool. And so with that, we'll kind of get started. So Giovanni Schiaparelli was born in March of 1835 in what is today northern Italy and close to southern France along the French Alp border, and what was then known as the Kingdom of Sardinia. His mother and father were Antonio and Maria Schiaparelli, and he had at least 4 brothers and 2 other siblings. There was a lot of conflict in terms of like naming his siblings because they aren't like, I saw like 4 different names for like the same sibling, and some sites were saying he had only 3 siblings, others he had 6. So I'm not quite sure what resource to believe here. So take the number of siblings was kind of a grain of salt, but 4 brothers is the most accurate that I had saw, or at least the most consistent. None of them, no real information I could find on anything else about his family. Unfortunately, it's kind of just a very dry bones around that, or even any much of his Schiaparelli's early childhood. In fact, the first thing we actually was able to find is where he when he began attending college. No records on any formal education before that, though presumably since he went to college, he did have some sort of formal education, especially in the 1800s. He attended school. He's at the University of Turin in 1854 with a focus in engineering sciences and hydraulics. So still kind of an engineering background. With him, kind of a weird transition to go from this over, well, not really weird, an interesting transition to go from engineering over into astronomy. But nonetheless, that's what he did. Shortly after getting his degree, the first job he had right out of school was he served briefly as a elementary school math teacher before he eventually moved to Berlin in 1857. He studied for 2 years at the Berlin Observatory, working on, I assume it was a PhD. It's not really clear if he was doing this as a job or doing this pursuing a graduate degree at the time. I know that, prior to like the 1870s or 1900s is kind of when they changed a little bit in terms of like the graduate school versus undergraduate school for universities. But he studied under a name that might be familiar to some, Joseph Franz Encke. I know that he's come up in some presentations from us in the past, but I don't remember off the top of my head where they were, but I do recognize his name. And then after his 2-year stint at the Berlin Observatory, he took a jaunt over into St. Petersburg, where he spent some time at the Poklow Observatory. Not really any records I was able to find in terms of exactly what he was studying at these 2 observatories. But upon his completion of a year at Poklow, he returned to Italy in 1860, where he took up position at the Berea Observatory in Milan, where he remained at the observatory until his retirement in 1900. One other thing to note, which I didn't actually put on the slide, is he also, about 2 years after joining the Berea Observatory, he became its director. So it's kind of a really big leap there. So his first big noticeable work is he discovered the asteroid Hesperia in 1861. This is a main belt asteroid. I can't remember its diameter off the top of my head. I wish I had actually included it in these slides. And some other notable works that he did is he was one of the first people that managed to show that meteor showers were the remnants of the comet trails. And he used what we now recognize as the Perseid Leonid showers, as well as which originated from what was then documented as the comet of 1862-3 and 1866-1, and showed that those 2 comets were directly correlated with the meteor showers and their after effects. He also provided some of the first real estimates for the rotational period of the planets Mercury and Venus. Because this is always one of those weird things where it's just like rotational period. So this is it the day or the year, and this is the day, which we're talking about here. He first calculated Mercury's day to be around 87.9 days. This original estimate was based on him assuming that, like Venus, Mercury was also tidally locked to the sun, which we now know is not true. The actual current estimate for how long Mercury's day is 59 Earth days. And this was actually not an official estimate. The original estimate for Mercury's dateline actually kind of stayed in the 80s until 1865, when the Mariner probes, I think it was the Mariner probes, first
1965.
1965. Thank you. Said 18 day.
Yeah.
I'm off by 100 years. Anyway, when in 1965, when the Mariner probes visited Mercury, it was able to get a more concrete estimate of its age from radar telemetry. His estimate estimated for Venus's age was actually a little bit short. He was still surprisingly close, in terms of like fractions of a percent, estimating Venus's day to be 224 days of the actual current accepted estimate of 243. So pretty good estimates for, tools and technologies of the day, especially since he was working from the ground without any of our, satellites or radar or anything that we had to kind of wait for that. So pretty good estimates, I would have to say.
Especially when since Venus has a thick atmosphere and you can't see any surface markings.
Mm-hmm. And also considering how little definition you can get off of Mercury, even in scopes that we have today, with what I can't remember what he was working as. I think the Milan was like the Berea's 20-inch or a 40-inch. No, I think it was like a 24-inch, something like that. It was a comparable telescope to what we can get now with like a 14-inch or 20-inch dial. So if you've ever looked at a Mercury with the scope like that, even then you still don't get a lot of surface definition. So how you're able to recognize a day from that is quite impressive. But his main claim to fame was a lot of his work on Mars. His initial, what kind of stirred all this up, actually is attributed to what was a mistranslation of his works. His initial observation of the planet led him to actually creating one of the first surface maps of Mars, which I have on the next slide. Being the first at something, you get to name a whole bunch of stuff. So he named what I think some of the surface features still bear his original names today, but I couldn't find a list of which ones that actually do. Naming the quote unquote seas and continents of the planets, because back then we assumed that Mars was like Earth. We now know that's very much not true. Working within the visual telescope. So where his controversy, well, not really controversy, but where his claim to fame stems from, came from an observation tour he did during Mars's Great Opposition event in 1877, which for those who do not fully know what an opposition is, that is the period in a planet's orbit when it is closest to the Earth, which also means it is the brightest and largest that it'll reach, with a great opposition signifying that it is an unusually close approach, which if you were aware of it, we had a similar event of Mars having a great opposition in 2020. This close approach and his gears allowed him to observe what he wrote as a dense network of structures on the surface of Mars. So obviously, one of his first maps of the planet. This is going. It looks mostly like the southern hemisphere, judging by the latitude and longitudes of this. Going, but there's still some elements here, like Elysium is still a recognized region. Hellas is still a recognized region, I think, as well.
Tarsus, Chryse.
Yeah, so still a couple of regions on even this original map that are still recognized as formal geographic regions. Geo is Earth. What is Marsographic? I don't know. Feels weird saying Martian geography when it's not Earth. Anyway, So he took these observations, and about a couple of months later, he published a paper, and he termed these structures and the Latin word canali, which means channel in Italian. But because people can't translate things correctly, it was interpreted to be canals. And so people was like, hey, there's people making structures on Mars, because obviously you associate canals with being something man-made. They're not natural structures, they're not natural rivers. So this led to a whole bunch of speculation and quote unquote professional research, where people were just like, hey, yeah, there's aliens there, for a good period in the late 1870s and up into the 1890s. So it wasn't until the following opposition, in which was not a great opposition, it's just the next sequence of the next opposition in 1879, where people actually were just like, oh, hey, no, you're right. You're actually seeing something there on the surface of Mars. Because people were just like, they thought he was crazy at the time too. It's like, you didn't see anything. Those are artifacts. They aren't there. Maybe it's something wrong with your telescope. So they actually had, like all good scientists, they do a follow-up campaign where they say, hey, yeah, we can reproduce this. So, this, upon confirmation, this presented a great deal of research about water and life on Mars and what sort of life was there. His work, this paper actually was also the kickoff point, which prompted Percival Lowell to build Lowell Observatory here in Flagstaff, Arizona. But it wasn't until Vincenzo Sorelli, Latin Italian names, was actually able to show in the 1890s that what Giovanni was seeing was an optical illusion of his own telescope that he was using. It wasn't an actual feature of the planet. But even after that was kind of circulated and published, we still have some records of this. In fact, this rampant period of speculation about life on Mars is also the thing that inspired H.G. Wells to write the classic War of the Worlds. So we can indirectly thank Giovanni Schiaparelli for this book. Much of his professional work was mostly limited into into the planetary astronomy, not necessarily some of the deep sky objects, like some others in his period were working on this time, notably the Herschel family with their work on the NGC catalog. But Giovanni would retire in 1900 from his position at the Berea Observatory, and he would spend the remainder of his life serving as sort of like an astronomer historian, where he would focus most of his attention on Babylonian and biblical astronomy, using searching biblical records for things, astronomical events, and trying to determine what they were looking at in the sky. Like for example, tracing down what star was it that was over Bethlehem that was shining during the birth of Jesus, and that sort of thing. In his pursuits, he would end up teaching himself and master Latin, Greek, Hebrew, and Akkadian. And Akkadian is one of the languages that was spoken during the Babylonian period. So it wasn't quite clear if he taught himself these after his retirement, in which case that's quite impressive, especially in old age, to master 4 languages, especially considering he was in his 70s at this point. So quite impressive, very well-learned person. And wrapping it up here, some of the things that still bear his name, he has craters named after him, both on Mars and the Moon. The 2016 ExoMars lander bears his name, and he has a main belt asteroid, as well as Schiaparelli's dorsum on Mercury. So Mercury is not Mercury. Mercury's a planet. So a dorsum, I actually had to go look this up because I hadn't heard that type of features. It's a type of ridge or ridge line, not sort of like a canyon ridge. So kind of like not a terribly significant feature, but still one that does bear his name. And some quick references for those that particularly care. And with that, any questions? I know that that's kind of a short presentation. Like I had suggested, any questions about Johnny that hopefully that maybe I could answer? Again, it's kind of hard finding a lot of stuff about him.
Did Schiaparelli communicate at all with Lowell?
You didn't see any evidence that he did, but you know, an absence of evidence does not necessarily mean there was no communication. Considering Lowell didn't start planning, when did Lowell start planning the Flagstaff Observatory, in the 1880s?
I don't know, but when Lowell did all those observations of Mars and drew all those wonderful sketches with the canals and everything, and I just wondered if he had any communication with Schiaparelli.
If there was, it would definitely have been over a long distance letter, considering Schiaparelli was based in Italy and Lowell was here in the U.S. and you know communication is not nearly as fast today as it was back then. That is an excellent question. I don't know. It certainly seems likely. Any other questions? Okay, cool. So with that, Doug, I will turn it over to you.
Okay, let me see if I can do the screen share. There it is.
I'm taking a quick AFK to get me something to drink.
Yeah, take your time. There we go. Okay. All right, take a drink too. Okay. So this presentation is going to be a little bit off the track of what we normally do, but I'm hoping we'll have some fun with it. I actually would like people to unmute because I want to have a little bit of interaction while I'm going here. Because I'm going to ask people questions. Maybe they'll answer back. So, well, as always, I start my presentations with a bit of humor. Well, I found this one. So, what I think I see, what the neighbors think I see, what professional astronomers think I see, which is absolutely nothing, and what I really see, all very different. I like that. I think it's appropriate too. So this presentation has got some history in it, and I love to do astronomy history stuff. And so this has got some history in it. For those of you who don't know what you're looking at, this is the Flandreau Planetarium at the University of Arizona. Most of the people who live in Tucson who are attending, who are online right now for this presentation have probably been here. Am I right?
Yes.
Everybody's been here? Has it, how many of you people have gone into the planetarium recently?
Does that include going to using the restrooms during the
yeah, I mean, you walked in the door and
book fair?
you've looked around,
Yeah.
and somebody has, right? Okay, so if I remember right, last time I was there, there was all kinds of different exhibitions in the area in the front lobby, and there was a painting on the wall that showed a picture of the space shuttle and other trivial stuff. Anybody remember what was in the lobby prior to 1994?
No.
Bet I got a no out of
I think
that.
there was a big meteorite, piece of a
Well,
meteorite.
yeah, there was that, but there was something else in the lobby.
Moon rock.
A big painting in the lobby. The same place where the painting is today, but today it's all nonsense stuff, not very important. Now, there was a different picture in there prior to 1994. So a little history.
Tell us.
Yes, the Flandreau Planetarium opened in 1975, and it was originally commissioned to be built about 2 years before that. And as part of the commission to build the Flandreau Planetarium, which at that time, it was part of the University of Arizona Astronomy Department, the University of Arizona commissioned a local artist named Donald Cohen to paint a special mural just for the planetarium, an astronomy related mural for the planetarium. Donald Cohen, if you go to the Optical Science Center at the U of A, he's got a number of sculptures and some other paintings that were done at the request of the University of Arizona, and they're still there in the Optical Sciences Center. Our big special mural that I am talking about that was in the Flandreau Planetarium from 1975 until 1994 is no longer there, obviously. It currently resides at the Tucson Convention Center, and I had to go find it. There it is. It's called Man in the Universe. And what I find very interesting about this mural is it has a load of information about the history of astronomy in it. And I have a copy of one of these hanging on my wall that I picked up when I visited the University of Arizona in 1976.
Where did you find it at the community center?
I had to dig around. I went online and looked up the history of this mural, and there is a little bit of history. If you look up the artist's name, Donald Cohen, you look down in the bottom right corner here, right there's his signature for the mural, John Cohen.
Okay.
If you look up his history, you'll find 1 or 2 lines about this mural. That's all you'll find. And it says in there that the mural currently resides at the Tucson Convention Center. So I contacted the Tucson Convention Center and got a hold of one of the public relations manager people there. And she said, oh yeah, there is a mural we got from somewhere. She couldn't remember where we got it. And she said, yeah, it's hanging up above the doors in the West Gallery. And I had to get special permission to enter the convention center when there were no events going on, and they let me in, and they're doing construction down there right now, but they let me in and let me take pictures of it. And here it is, it's hanging on the wall.
No,
I'm
that's
sorry, Doug. Did you say how big it is?
It's about, forgive me,
Much
my
brighter.
security stuff just kicked off. Let me close this out fast. It's like 14 feet by 8 feet or something like that. It's a pretty
Okay.
good sized mural. All right, when you look at this mural, you're supposed to start in the bottom right corner and go around it in a clockwise fashion. That's the general direction that you go if you want to go with time. Time advances clockwise, which is kind of what you'd expect, right? But the names in here, the people that you will see, just everybody. So like here, this is supposed to be an indication of primitive man. They're looking at the sky, but they're scared of everything. They're scared of the darkness. They don't understand the heavens. They're scared of the heavens. And there you see behind the mountains a total solar eclipse of the sun occurring. And they're totally terrified of that. They look like these are scared people, primitive man. But you see this man on the ground here on the left. He's holding a tool, a primitive tool, and he's crawling towards the, if you like, more civilized part of the mural. He's kind of moving in that general direction towards the more civilized area of the mural. So you could look at it that way. Right next to him, Stonehenge. And Stonehenge, we all know, has some astronomical connections. It aligns with the summer and solstice and the winter solstice, and it has other features that are astronomical in nature, and that's pretty old too. Probably about 5,000 years old, and so the people at that time were paying attention to the heavens, probably using as guidelines for when to plant crops and when to harvest crops and other stuff of that nature. Moving a little farther to the left, we're getting into the first, what you'd call civilizations, advanced civilizations, ancient civilizations. You got the Babylonians and the Egyptians, and here you see Egyptians building the pyramids. You see an Egyptian engineer here who's taking alignments with some kind of a tool, but they used the stars and the suns to align their monuments, and they paid a great deal of attention to the seasons, and they measured the seasons with the stars and the sun and the moon. And down here in this corner, this is an old model of the universe, if you like. You've got a flat Earth with a sea that surrounds the land that the people are on, and you could fall off the edge of the sea. And you've got an underworld underneath that down here, and then you've got things in the heavens that are arcing overhead, and that's their model of the universe, if you like. So, but they were paying attention to the heavens. And then over here, this whole side of the mural from top to bottom, over here on the left side, I'm just going to call, here are the Greeks. And we have a lot of famous name Greeks. We have Euclid right here. We all know what Euclid did. He invented modern geometry, and here's a perfect example. He's got a pyramid with a circle embedded in it, and then he's got some other text here. And then here's one of my favorite Greek guys, a Greek astronomer, Eratosthenes. He was the first one to come up with an accurate measurement for the circumference of the Earth. If you remember last month's presentation on, what was it that Pete did? Was that you, Pete, that you did that last month?
No, not me.
Oh, somebody did a presentation on something. But Eratosthenes, he was the one who made an accurate measurement of the Earth. And, oh, I'm sorry, that was at the general meeting just the other day.
Oh yeah, the archaeastronomy. Yeah.
Yeah. He noticed that, or he had read in a manuscript somewhere, that if you had a twice a year, or sorry, once a year in the summer solstice at where is currently modern day Aswan, Egypt, the bottom of a well was completely lit by the sunlight. That the sun was directly overhead. But farther north in Cairo, a stick in the ground cast a shadow. He was able to measure the angle difference between the shadow and vertical, and determined it was something like 1/20th or 1/30th of a circle, and deduced that that represented 1/30th of the circumference of the Earth, the distance between Aswan and Cairo. And he measured that distance out. He actually had someone pace it, walk the entire distance and measure it in paces. And he paid them to do that, and deduced an accurate measurement within 5% of what the actual circumference of the Earth is. So he deduced that the Earth was round and deduced the circumference. So he's one of my favorite Greek people, Eratosthenes. I like that name. Right above Eratosthenes is, let's see, more Greeks.
Could be Ptolemy.
I think you're right. I'm not sure. I got to
He's
check.
got his diagram of the solar
Yeah.
system
Yeah, that was Ptolemy.
with
You're
the Earth at
correct.
the center.
Yep, yep, I got a Eratosthenes. Standing. Yep. No, that's not Ptolemy. That's Hipparchus. This gentleman here is Hipparchus. And Hipparchus, in addition to developing a stellar catalog, he also came up with the idea of what we call epicycles to describe the motion of the planets in their orbits. They didn't yet know that orbits were ellipses. They believed that orbits were circular. And he used this notion that on the big circle of the orbit, there were these smaller, what they called epicycle circles to describe the motion of the planets that you see in the sky. And that was one of the things Hipparchus was famous for. More Greeks. Up in the upper left corner, you have Plato, and right in front of Plato, the big character is Aristotle. And Aristotle was holding a model of the universe that's a celestial sphere with the stars on a sphere and the planets all circling in orbits. And the Aristotle model had the Earth at the center of the universe. And he's holding this model in front of him. And then the guy dressed in pink here. That's Ptolemy. And Ptolemy developed a catalog of stars. And he also was very big on epicycles. So you notice that both Hipparchus down here in the bottom left here and Ptolemy are both pointing to this diagram because they both had a lot to do with the epicycles of the planet rotation. So those are the Greeks. Now, oops, no. Now we come to what's called the Dark Ages, as I call it. Right here in the center of your image, right there, that's the burning of the Library of Alexandria. And that is what you would consider the start of the Dark Ages. That represented a tremendous loss of knowledge to humanity, probably 1,000 years or more. There was, I mean, there are just a few remnants of some of the original scrolls can be found in various museums. But from those remnants, you get an idea of what kind of knowledge was in this library. For instance, there was a book that was written by various Greeks and other people that deduced that the planets did not orbit the Earth, that the planets orbited the sun, that the sun was a star, and that the stars were extremely far away, too far away to measure a parallax in those days, and so they consider them, and that the speed of light was not infinity, that it was some fixed speed, but very fast. All of that knowledge is true, and yet it took, what, another 1,400 years for it to get rediscovered by Europeans after it was all lost when the library was destroyed.
Doug, what precipitated the destruction of the library? What was the cause?
Julius Caesar?
Oh, okay. So it was intentional.
No, it was not intentional, actually.
Oh.
It was accidental. Julius Caesar was under siege in Alexandria, and he decided to burn the Egyptian fleet, which was in the port of Alexandria, and the fire spread to the library.
Okay.
And being soldiers, they didn't do firefighting duties, so the library burned. So that's that. Now, some knowledge was preserved during the Dark Ages. You notice standing here is a Chinaman, Chinese gentleman, who he's actually using some kind of an instrument. And what he's observing is the supernova of 1066, the Crab Nebula supernova.
Oh, yeah.
He observed it. So the Chinese, they had observatories and they observed the heavens, and they did things. Also, throughout the Muslim world, there were Muslim scholars and philosophers who also preserved some of the scientific knowledge during the Dark Ages. The Europeans didn't go in much for scientific knowledge. Basically, religious zeal took over for logic, if you like, and anyone who was a free-thinking person who didn't agree with literal translations of the Bible could be accused of heresy and burned at the stake. I mean, the logic went out the window during the Dark Ages in Europe. But the Muslim world, they still had free-thinking scientists, people. Omar Khayyam is one name. He was a famous Arab astronomer and philosopher and scientist. And here you see an Arabic gentleman. He's looking at a rod that's stuck in the water, and he's observing the refraction properties of water. So he's doing some scientific observations there, and that's what that's supposed to present, is that, all right, there's a little bit of something going on during the Dark Ages, and not all bad. But you could see up here on the right, on the other hand, you see people being burned at the stake for heresy here. And here's a religious guy, a monk, if you like, but he's kind of like looking at what's going on. Another thing that was of interest during the, let me see if the next slide shows it. Nope. Another interesting thing that happened during the Dark Ages, which was very important to human advancement in general, but is this little thing here is the invention of the printing press, the Gutenberg Bible. That obviously had repercussions on everything. Now you get to some more important stuff. Now you're starting to come out of the Dark Ages. Up here, though, okay, first of all, I'll go here. This is Copernicus. You can see him, he's down here, he's on his deathbed in this image. And he is holding down here with his right hand, he's holding a manuscript drawing of the planets revolving around the sun. And with his left hand, he's kind of pointing towards Aristotle, as if to say, you're wrong, Aristotle, or something. He's kind of pointing that way. But notice the figure standing over him. That's a religious figure, a Vatican figure, kind of holding the Holy Script in front of him, saying, you're on the borderline of heresy, and you should confess your sins and whatever, and he died in disgrace from the church. Right over this guy's shoulder is another famous astronomer, a guy named Bruno. Bruno was a famous astronomer from Europe who strongly believed in the Copernican theory and also believed that stars were extremely far away, and he was crucified for his beliefs. He refused to confess his sins. He refused to recant on his beliefs, and he was burned at the stake for it. Yeah, church was not kind to astronomers back then. And then, of course, we have Galileo. And here you see Galileo. He's sitting there in front of one of his telescopes right there. He also builds a mechanical clock, and there's a mechanical clock. And here's or what do they call it? An orator sphere, where you can get the planetary orbits and stuff in this map out like a globe. But he was censored by the church, and there's the ever presence of the church standing right in front of him. That's a soldier from the Vatican. And there's a cross sitting right here on his hand, symbolically showing that he was under extreme censorship by the church. He was not crucified, but it took hundreds of years before his works were finally published without being censored by the church. And then you move to a different part of Europe where the church isn't so powerful, and you have these people. You have Johannes Kepler right here. And he was the one who deduced the orbits of the planets as being ellipses and came up with Kepler's laws of planetary motion. And down here on the table is some of his paperwork and diagrams from some of his original manuscripts. And sitting in front of him is this model of the 5 perfect solids, because he spent a lot of time trying to mold the planet's orbits to fit these 5 perfect solids. Wrongly, that obviously didn't have anything to do with it, but they didn't know about gravity at this time, so they didn't understand why the planets orbited where they orbited. And Tycho Brahe is the guy who's standing over his shoulder, because Kepler used the observations of Tycho Brahe to deduce the laws of planetary motion. Okay, and then standing next to both of them is Isaac Newton. And Isaac Newton, there's in front of Isaac Newton on the table is the telescope that Isaac Newton built, little reflector telescope that is now named after him. It's called a Newtonian reflector, which is a common telescope today. And Newton is symbolically throwing a satellite into orbit with his hand. Kind of a way of showing that he deduced gravity, and now you can understand how a satellite goes in orbit. So I figured that out. And behind him is an image of Halley's Comet, because Newton was the first one to actually predict when Halley's Comet would return. Based on his theory of gravity, he was able to predict when the comet should return, and it did return right on schedule. And back in the background here is one of William Herschel's telescopes, Herschel being a great observer of many different things in the night sky. Those are important characters. And down here, this is a gentleman you probably wouldn't normally think of as related to astronomy, but is very much related to astronomy. That's Fraunhofer, who invented the spectroscope. And you see him symbolically taking a spectrum of a star using a prism and projecting the spectrum down there on the lower right. And obviously, spectroscope is one of the most important instruments that astronomers use. And then here you have, obviously, Albert Einstein. And Albert Einstein came up with the theory of relativity in the early part of the 20th century. And the theory of relativity had enormous consequences to astronomy, because it provides the baseline, the E equals mc squared, provides a baseline to help you understand how stars operate, how they perform their nuclear fusion and produce energy. So that was extremely important. But you notice if you look at him, and you can't really tell from my picture, if you get up real close to the mural, he's got kind of a troubled look on his face, because he's looking at 2 possible futures. You see him looking off towards the future. And if you look at the future, there's 2 scenarios. You see a city being blown apart. And then over here, you see a city that seems to be thriving. So he sees this discovery of nuclear power, if you like, or discovery of this magic power of the universe as it could lead to a lot of wonderful things, but it also has its darker side. So that a troubling aspect to his discovery. Then you come over here to some more modern people. And I have got to get this out of here. Oops. So over here, you see some more modern, interesting people that we think of today. First of all, one thing you might notice is this telescope right here. That is the 100-inch Hooker telescope on Mount Wilson. Okay. This gentleman here, this is Harlow Shapley. And this gentleman down here is Eugene Curtis. These two astronomers of the 20th century were responsible for one of the what they call the Great Debate, which was they debated whether nebula, which is at that time, that's what galaxies like Andromeda Galaxy or the Pinwheel Galaxy, all these galaxies that we now know today are galaxies. Back then, they were called nebula. And there was a great debate about whether these nebula were part of the Milky Way or outside the Milky Way. Harlow Shapley believed they were part of the Milky Way, and Curtis argued the other way around, that they were not part of the Milky Way. Curtis obviously won the argument, but they're holding a picture. They're both holding this picture of M31, the Andromeda Galaxy. That's their debate. Up here above them is Edwin Hubble, who basically settled that whole argument about that galaxies were outside the Milky Way. And he is shown symbolically measuring the size of the Andromeda Galaxy right here. And here, the only woman in the whole mural, we should all know who she is. I've given a couple of talks on this woman. This is Henrietta Leavitt, who she discovered the relationship between Cepheid variables period and their absolute magnitude, their luminosity, what they call the luminosity period relationship, which is key. It's one of the cornerstones for measuring distances to objects outside the Milky Way. And she's holding in her hand a picture of the large Magellanic Cloud, because that was her prime object that she studied to derive that period luminosity relationship, if you like. So, okay, so I reached the, and some other things in the mural that are interesting is, that's actually the last slide. Oh, no, it isn't. Okay. Some other interesting things, if you look at this mural, you've got a nice radio telescope. That's the Jodrell Bank radio telescope. You've got Skylab up there floating in the sky. I keep losing my cursor. And another thing that's symbolic about the mural is if you start here in the bottom right and you go around, each of these little vignettes, if you look at the sky background in each of these vignettes, it's usually cloudy and hazy and you don't see much until you get into this area where you start getting to Kepler and Newton and people like that. And then all of a sudden you're seeing the universe in the background is actually coming through. We're understanding it. So anyway, so that's my little talk on this wonderful little mural that's gotten lost.
Well done.
Questions?
That was really good. Thank you.
If you guys, anyone, if you guys ever get a chance to go down to TCC, try to get a look at it. I wish there was some way we could get it back from the TCC because it's going to get lost there. They're going to get rid of it eventually. It's going to probably end up getting tossed in the trash somewhere because no one's going to want it.
When was the piece finished, you know?
Huh?
When was the piece finished?
Let's see. 1975.
Okay, so well, so ostensibly it was created for the planetarium?
Yes, it was commissioned
Okay.
by the University of Arizona
Gotcha. I missed
for,
that.
for the planetarium. And the commissioning for the University of Arizona decided to build the planetarium in 1973, and they commissioned Don Cohen to build the mural in 1974. And it was removed from the planetarium in 1994.
Were you able to determine why? Was it just so the Flandre wanted to redo their interior and
Well, so from what I gather, when I talked to the people and asked them about it, first of all, there aren't many people who even remember it. No one at Flandre remembers anything about it. So I had to dig a bit. They did a major renovation on the planetarium in the
Okay.
early 1990s. And part of that renovation was it's no longer part of the astronomy department. It is now
oh, okay.
just
I got you.
University of Arizona Flandre Planetarium and Science Center. Okay, so it's no longer associated with the astronomy department. And as part of that renovation, they did a whole lot of remodeling on the inside, new projectors for the planetarium and all kinds of other things. They decided to do a thorough changing of all their exhibits to make it more, the word I guess you would use, and I hate this phrase, family friendly.
Yeah.
Wow.
And so they kind of turned away from being a special planetarium for astronomers, which it was, because I remember going there, like I said, I remember going in there in 1976, and there was nothing in that planetarium except stuff about astronomy.
Oh, okay.
There were no exhibits related to the space shuttle or the space program. There were no exhibits about dinosaurs. There was no exhibits about geology, no exhibits about insects. If you go in there today, you will find all of those. Okay, it's now just really a science center. And the only reason they still call it a planetarium is because it still has the planetarium. Okay. But it's really a science center. So they did away with the astronomy, theme that they had, and they switched it over to this more family-friendly science center. And I'm sure with good reason in terms of they wanted to attract more people, classrooms, students, etc., from all the schools in the area and stuff come out and visit but as a result, this guy got sent off, and it didn't get to TCC until several years later. It actually sat in storage for a long time and then was
not good.
donated to TCC. Now, when I went down to TCC and talked to these people, that lady that gave me permission to get in there and take the pictures, she didn't even know what it was. She didn't know that it had anything to do with
Oh.
astronomy at all. She just said, oh yeah, there's this mural that looks like it's about the evolution of man. It's like, well, I'm sure that's the one. And she said, yeah, it's got a couple of telescopes on it. And it's like, that's the one, But I'd like to see it. Frankly, it'd be nice if the TAAA would buy it, hang it up in the learning center out at CAC or something, so it doesn't get lost.
For art museum? And go to an art museum, maybe?
I don't know.
What
I
is
don't
the
know.
medium, Doug?
It's
Is it oil on canvas,
I
oil on
think it
board?
is. I think
Okay.
it's oil on canvas. I couldn't get that close to it, and I don't remember when when I went there in 76 and saw it, you could get right up close. I mean, within 3 feet of it. Okay, because it was hanging on the wall at eye level. You could get right up there next to it. Okay, but I don't remember. But I'm thinking it's oil on canvas.
Okay.
So yeah, I'd like to see it get away from TCC because they're not going to They don't even know what it is. They don't understand it.
The
It's-
Learning Center would be a good place.
Yes, it would be a really nice place. And I'm sure it would fit. I didn't, I don't think it's that big. It's like 14 feet by 8 feet or something. I'm sure we could find it. That learning center is big enough to hold it, I think, somewhere. I just would hate to see this thing disappear because I don't know of any other paintings or works of art, if you like, that have all of this astronomies that are astronomy themed in this way. You got all the important characters.
Do you
on this-
think the artist did his own historical study or was he?
Oh,
coached?
yeah, he apparently spent a lot of time doing the research and coming up with, who he wanted to put in here and how he wanted to portray him. He's what I read about Donald Cohen is he was very much into history. He liked doing history stuff in his work. He very much enjoyed that.
It's fabulous.
Yeah. Okay, I'm going to stop sharing.
Doug, that was really great. Thank you so much.
That was
Yes, it
terrific.
was.
Yeah.
Interesting topic.
Different, but I thought worthwhile.
Yes. Thank you very much, Doug. That was actually a pretty cool topic. It's always cool to see some of the art that you just don't ever have a chance to
Well,
get a dissection of.
when I first moved to Tucson in 1997, one of the first things I did, of course, was come down to the U of A for an astronomy meeting, to join the club. And of course, I went over to the Flanders Planetarium because I had remembered what it was in 1976. And I was so disappointed when I walked in the door and didn't see this wonderful mural. This mural used to be almost the first thing you would see when you would walk in the door. You would walk in the door where the gift shop is, and there would be that hallway leading away from the gift shop down to the left, I think it is. And this thing was right there in that hallway on the wall. It literally was the first thing you saw after you left the gift shop. And I went in there and it's like, where's the big mural? And instead they had this kinky painting that looked like it had been painted by kids with a picture of a space shuttle and some other stuff on it. I don't think that's there anymore, but I mean, it's like, really? And the lady at the gift shop, I asked her, what happened to the mural? And she didn't even know what I was talking about. It's like, oh, that was a big disappointment.
We need to figure out how to get our hands on this.
Yes, I agree.
Cool. And with that kind of wraps up this month's meeting. So Doug, for next month, I have you down as doing lunar craters still. Is that still the case?
I can do that.
And Pete, I know I had you down for as a tentative for September as well on a topic.
Yeah, I was thinking of doing Ptolemy. And why don't you put it in for September? I should be fairly clear on my schedule. If I run into a problem, I'm on the road right now, I can still participate and make a presentation. Just if something untoward happens during a certain day, but especially since I'm 2 hours east of you, it was a lot easier to get on tonight with my schedule. So yeah, why don't you pencil me in for the September meeting doing Ptolemy, if that's okay?
I have you down for that.
Okay.
Cool. And also, I'm not going to be able to host the December meeting. I will be in New Zealand.
Yeah, so you just have to get up a little earlier, don't you? No, that'd be morning for you.
It's an 18, it's like a 16-hour difference.
Oh, really?
Connor, New
Yeah.
Zealand in December. You should get some decent weather for observations down there.
Oh, yeah.
It'll depend.
I know it's summertime.
It will be. It's just a matter of, am I going to be in a dark enough sky position to go do it? Because I'm going to be backpacking in New Zealand and Australia with my brother.
Okay.
So,
Well, at least
I'm
take
obviously
some-
not going to be carrying around a telescope with me. But I
take
do.
binoculars.
It's one of those travel light things. I will have my camera and a tripod on me, but it's anything more than that is, I need to have room
That's-
for souvenirs and things.
Take some
Um,
tiny binoculars.
Yeah, well, I will be trying to get a picture of the Magellanic Clouds because I know that they're in a observable position that time of year.
True.
So that's going to be the big thing I want to target. And Doug, I know that you typically take a cruise around that time of year.
We don't have anything scheduled yet, so.
Okay. So we'll play December by ear if we can have it, if we can get somebody else to run it then while I am out of town. But I just wanted to give some people a fair heads up on that. And cool. So thank you all. I'm going to go ahead and end the recording here for this month.